Well, the stem tells us that the combined time for K, M, and P all working together to do a job is 24 minutes. And we can actually pull an equation out of that information, and one way to do that is to organize our thinking with our add up the individual rates to get the combined rate formula. So what's their combined rate? The combined rate of K, M, and P all working together. Well, a rate is some amount of work per some amount of time. And we're told that K, M, and P all working together take 24 minutes to do a job. And how much work do they do in that time? Well, it's just one job. So let's just say they do one job, one task per 24 minutes. The other half of the equation, we can say K's rate is one job per K minutes, and M's rate is one job per M minutes, and P's rate is one job per P minutes. So we've got one equation, three variables. What's the variable we care about? Well, they're asking us, how long does it take machine K working alone at its constant rate to complete the task? So this is the variable we ultimately want. Because that number does represent how much time it would take K to do a single job. So to answer this question, to get enough information, we're either going to need two more equations that involve these three variables. Then we'd have three equations, three variables. Or we'll just get enough information to get rid of both M and P in one go. Let's keep that in mind as we go to the statements. Statement number one. Statement number one tells us that M and P working simultaneously at their respective rates can do the job in 36 minutes. M and P working together can do the job in 36 minutes. Well, we can pull out a very similar equation. The combined rate of just M and P is one job per 36 minutes. And their rates are the same. M's rate is still 1 over M, and P's rate is still 1 over P. We've got a second equation. I guess now we've got two equations, three variables, so we're not going to be able to solve for every single variable in the mix. The question then is there a way to get rid of both M and P and leave just the variable that we want, the K? And in fact, with them lined up nicely like this, we can see that, if we just take this whole second equation and subtract it from the first, subtract this whole second one from the first, well, the M terms are going to disappear and the P terms are going to disappear. So, let's do that. Subtracting this whole second equation from the first, what do we get? 1 over K minus nothing. There's no K term here. Just leaves us with 1 over K. 1 over M minus 1 over M is nothing, plus 0 for the M terms, plus 1 over P minus 1 over P is another 0, equals 1 over 24 minus 1 over 36, and now we've got one equation with one variable. We could solve this. We could isolate for K. Let's not do that because it'll be a waste of time since we already know that statement number one is sufficient. And therefore, we already know that B, C, and E are all eliminated. All right, on to statement number two, and I will get rid of statement number one because I want to consider statement number two on its own. So getting rid of statement number one, and on to statement number two. Statement number two tells us that K and P working together at their respective constant rates can do the task in 48 minutes. So again, we can pull out a rate equation. We can say working together, their rate is one job per 48 minutes. Their individual rates are still just 1 over K and 1 over P. All right, am I going to be, well, again, we've got, two equations and three variables, so can't solve for everything. So we've got to say, can we get down to just a single equation with just K? Well, the trick we used last time is not going to work here, right? If I subtract equation 2 from equation 1, Well, that'll leave me with a term with m, which will be nice. I could solve for m, but m is not what I want for this question. I want k, so subtracting one equation from the other is not going to help. And you might think for a second, well, if I were to solve this equation for p, and then I'd plug in some term with k up here, but that's not helpful because I've still got an m in the mix. So from statement number 2, we are unable to combine these equations and just leave k. So statement number 2 is insufficient, and that means that we click A.